So how do you solve a problem? People have been solving problems for a long time, whether it's two brothers that don't get along, whether it's who's going to run your country, whether it's what I'm going to eat for dinner, we always have problems that we're trying to solve. Now, within software development, these problems that can arise within your programs are called bugs. And there's different types of bugs that we have to apply our problem-solving skills to fix. When we apply problem-solving skills to fix a bug, we call that debugging. What type of bugs are there? Well, the different bugs that you're going to encounter during programming are going to be bugs like coding bugs. Coding bugs are actually errors that you make while writing software. Maybe you don't put a semicolon. Maybe you don't end an if statement. Maybe you type something wrong. Those are code or source code errors or bugs that you have to fix. Another type of bug you'll see are called logic bugs. These are harder to find because they're not the software bugs that when you compile your program, the compiler says, hey, dummy, you made a mistake right here. Type this right next time. Type lowercase versus uppercase, things like that. Logic bugs say you wrote the source code correctly, but the way the source code on your program is executed is not correct. Maybe it's doing something that the system shouldn't be doing. Maybe it's not accomplishing the goal the user wants because you're doing it your way rather than their way. Another type of bug that you're going to run into can be a data bug. Because if you have bad data is going to affect how you get your job done. It could affect the reports that you print. It could affect purchasing decisions. It can affect what classes you want to register for. Anything you want to do, any data that you collect, if it's bad data, it affects your decision. We often call that GIGO, G-I-G-O, which stands for garbage in, garbage out. Another bug that you might run into is what we call compatibility bugs. This could be maybe it works fine in one browser like Chrome, but it doesn't work in Internet Explorer. Maybe it doesn't look the same. Or maybe it works fine on one operating system, but doesn't work on another operating system. And the last type of bug you might run into are called hardware bugs. And these are associated with things like your computer or your monitor or your printers or anything like that. For example, the new 4K resolution monitors. Some applications don't work well on them. NetBeans isn't really happy trying to display on a 4K resolution. And so that's considered a hardware bug. And all these bugs are things that you're going to have to do to problem solve to figure out how do you have success and make things work. So how do we actually problem solve? Well, there's 12 different steps I think that you can apply to help you solve a problem. The first step is I will own the problem. That means you're going to be patient, you're going to think positively about this, not negatively, and you're going to say, I'm going to solve this problem. I'm smart enough, I'm responsible enough, I can get the job done. The second step is a hard one. You're going to remain calm. When you panic, all it does is make things worse. It stops your train of thought. It makes it to where you can't remember things. It makes it very difficult to be successful. So just be calm, be patient, and realize you have the skills to be successful. The third step is you're going to apply the scientific method. This means you're going to observe what is happening. You're going to think of a way to solve that problem. You're going to test if your solution worked. And then you're going to go keep repeating those steps until you finally did solve the problem. Step 4, go Google. Search the internet, read a manual, read a book. You don't have to just give up. You don't have to immediately go to someone else and say, I don't know how to solve the problem. Do some searching on your own. That's what industry wants you to do. They want you to figure out the problem. Otherwise, they'd just do it themselves. The fifth step, I will try to break the code. In other words, WWTUD, what would the user do? The user would never type that in. Oh, yes, they will, and they will type it. They'll never click on that button. Yes, they will, and they will click on it. You want to try to make your source code or your program user-proof. It's not that users are stupid, it's just that they do things. And we have to think, would the user ever try to do this? And if we even think that, then it probably means they would. The sixth step is, I will not assume. Don't make assumptions. When you make an assumption, you're probably setting yourself up for disappointment. Sometimes you're right, but you could also be wrong. The next step, I will eat the elephant one bite at a time. Now that might sound gross, but what does it really mean? Don't be overwhelmed with the project or the problem you're trying to solve. Just do one little piece at a time. If you do it one piece at a time, you make progress. When you make progress, you gain confidence. And when you gain confidence, your skills and your ability to solve the next problem increase. So just take it one little piece at a time. The next step is fix one piece and then test it. You don't have to try to do the whole thing and test it all at once. Make sure the one little piece works before you go and try to fix the next piece. After that step, you really need to keep a log of all the changes that you're making. And don't tell yourself, oh, I'll remember this. I'm the only one that's going to work on it. You won't remember it. A year down the road, you won't even remember you wrote that code. The 10th step is that you're going to ask other people. After you've Googled, after you've tried to solve the problem on your own, if you don't understand it still, swallow your pride and go ask for help. Companies don't mind if you ask for help, but they do mind if you just sit there spinning your wheels doing nothing. The 11th step is, once you've made all these changes, now test the whole thing again, because you never know if your one little change is going to break something else that used to work. The very last step is going to be preventative rather than reactive. Think ahead. Always ask, could this cause a problem? If so, I'm going to solve it now rather than having to solve it later. If you follow these problems or these steps, they'll help you solve problems, you'll gain confidence, and the more confidence you gain in solving problems will make you a better problem solver.